John is absolutely correct. He actually lived in Aptos, so it's Aptos, not Aptos. Thanks for the intro, John. Today we're going to talk a little bit about Aptos, obviously, but I think we wanted to discuss some of the broader themes in Web3 and some of the challenges in the space and talk about applications as well. So I think this will be an interesting talk with respect to, hopefully, how we see adoption happening in Web3 with respect to not just protocols, but applications in the space. Oh, sorry. Great. So just kind of running through the agenda a little bit, we'll talk a little bit about where we are as an industry in terms of the way adoptions happen, blockchain versus the internet, how those things collide. We'll talk a little bit about some of the challenges we think are kind of blocking the major adoption of blockchain towards getting to internet scale. And finally, we'll talk a little bit about industry applications and verticals that we find extremely compelling and how we start to see some of the signs of those applications starting to move forward in this space. So first stage is just thinking a little bit about the internet itself. Where are we now? A lot of companies back in the day started to run services on-prem. And cloud computing has been really huge coming into the industry and transforming it, starting with AWS and continuing with GCP, Azure, and others. And we see that now, like in a couple of years, the spend for cloud will actually exceed the on-prem IT budgets for most of the industry. And that's pretty exciting. And then when we think about how cloud adoption came to be and how that affects Web3 specifically, it's good to look at some of the parallels. And so what was very compelling about cloud? First of all, you could take a piece of software, you can compile it, you can build it anywhere on any machine in the world, and you can run it anywhere in the world. And that containerization and VMs were really interesting in terms of how we think about deploying software at scale and not just on your own environment. There was a lot of worries and concerns that would cloud be safe for your application? As customers, as big as, say, Meta, which I was at for more than 10 years, started to look at, can we trust cloud with our applications? Can we trust them with our customers? If there's an outage, what happens? If there's a security breach, what happens? And over time, I think cloud's proven that some of the best security infrastructure can be built at scale and support many, many companies in the world, not just the startups, but also even some larger institutions that can rely on cloud for their biggest use cases. Service infrastructure was huge because in the beginning, people thought about only how do you deploy more machines? How do you get more scalability in different regions in different places of the world? And then you see the ideas of managed services like Spark and Presto starting to take advantage of that. And in the old days, most of these applications were deployed on-prem. So when I worked at Yahoo before this, we were developing Hadoop and running it locally in our own data centers. And when I was at Meta, we started to deploy our own version of Hadoop into our own clusters. And then you see Amazon and Google and Microsoft starting to deploy managed cloud services, managed Spark services, and managed Hadoop services to take away the operational pain of having to do it yourselves, and also to handle the scaling parts that not every company can handle internally, because those teams are huge. The infrastructure investment is gigantic. And so serverless infrastructure has been massive to actually getting startups to product market fit much faster. And then you can imagine not just these kind of managed services, but even things like cloud computing through Lambda services and even more simplified infrastructure has been really tremendous in terms of adoption of the cloud. And the final point is kind of like, how do you think about scalability? How do you increase and decrease hardware in different kinds of data centers, and how this has been able to manifest itself towards internet adoption and services running in the cloud? And so when I think about these things, I am really reminded about where we are with the blockchain use cases and people having the same and similar concerns. Is blockchain going to be safe for my applications? If I'm a large enterprise and I start to depend on them for customer-facing activities, is it something that's going to be going down or something can handle my workload? If my workload expands, will it be able to scale and support the bigger use cases and broader use cases going forward? How does this VM support the applications and workload I want to do? Is it flexible enough? Does it have the right parameters and the right path towards upgradability towards those use cases? And so I see the parallels very strongly between kind of where cloud adoption happened for the internet, the way that blockchain needs to be adopted as well. And if we think about where the industry in terms of usage and adoption is, and in terms of the general population, there are roughly 8 billion people in the world today, and a good chunk of those people, like more than 60% of them, actually use the internet, which is amazing. And kind of our best estimate, because we don't actually have real user numbers for blockchain, is something on the order of 20 million-ish wallets, monthly active wallets across all the industry. And that's probably a high estimate, if we're honest, because a lot of those wallets are going to be duplicates, duplicates of users. There's no way to kind of dedupe those and kind of get that estimate. So if you kind of upper bound the 20 million monthly active wallets, you're talking about roughly one blockchain user for every 250 internet users. And another way to think about it is basically 0.25% of the population is using Web3. And so this is just another way of me saying we're really, really early. And it's amazing if you look around here, like all the different kind of projects going on, the excitement and the learnings. But it's kind of a good reminder for us that still things are in the nascent stage, and we should expect lots and lots of changes to come, and that's good. That's a great place to be. If you look at the slide, I think from ACC&Z, their State of the Union, State of Crypto, we're somewhere between 1996 and 1997. So we're decades behind where we were at the internet. And so our goal as an industry is really about how do we accelerate adoption of the blockchain to every internet user out there. And we think it kind of comes down to three different problems we need to solve. The first is user experience. It's so easy for me to go into Amazon and buy something with one-click shopping. It's tremendously simple, right? And even to return things, it's easy. It's simple as me as well to go into my banking website and transfer money to someone else. Not having to sign into a wallet, not having to remember seed phrases, not having to worry that if I mess up, I'm going to lose all my funds. And if I'm playing a game, it's really simple for me to log into a game and then just not have to worry about anything going on, and the game server takes care of everything for me. And so those user experiences for the internet today are incredibly good, and they've been optimized over decades to provide us simplicity, seamless interaction, and make us very productive, right? As Google starts saying, their goal is to actually get customers off the web page as soon as possible. They want to get their search results and spend less time searching. So that's kind of, again, where we need to improve a lot. And so a couple of things that we can do is think about how we interact with the blockchain and how we do transactions. They need to be intuitive, safe, and easy to use. Our UI as an interface needs to be able to kind of support fewer clicks to action and safer clicks. There needs to be easier ways to create your account. Today, it's very simple to go into Google, create a new user account, and then use that account to log into many different websites across the world and keep one identity there. Obviously, that's something that we need to improve as well for industry. And auditability is an area where blockchain really shines. You can see when you've created an account, you can see when you rotated your keys. You can learn all these things on-chain because they're public, verifiable, and transferable. And so we should take advantage of that from the user experience side. Going back to kind of our premise earlier, though, scaling blockchains is really about like how we think about scaling the cloud. And so what that means is a couple things. One is, as you start to expand your business, you shouldn't be afraid of the fact that blockchains will hit an upper bound in terms of throughput, or that you're going to run into latency issues, or a noisy neighbor on the blockchain is going to cause your application to run into high gas fees, or bad customer experiences due to latency. Cloud takes care of that for you today, right? You have elastic scaling. You can actually scale up and scale down your infrastructure. You can support more hardware, and different types of hardware, in fact, if you want to, with more compute, more memory, SSDs versus hard drives. And so over time, we have to see blockchains kind of take on this ability to increase their resource capabilities, as well as support different kinds of models for flexible computing. And kind of the third thing that's missing is that even if we have a great user experience and we have an amazing ability to scale blockchains similar to cloud, is that the applications are missing, right? Today, I always love to ask people what they do in Web3, and most of them are going to give the simple answer, well, I like to liquid stake my tokens on Ethereum, and I like to go OpenSea once in a while. And those are great things to do. Some people like to do DeFi, and trade heavily, and that's great too. But in terms of getting mass adoption, we are still yet to kind of see these applications gain massive traction. And so we've identified a couple of the different verticals that we feel are ripe for adoption. So taking these things into mind, let's talk a little bit about what it means for layer 1. And specifically for Aptos, it's influenced our design decisions immensely. So the first point is that as we thought about what would kind of advance the state of the art in this space, we thought about the programming language itself. How do you get from ideation to production as fast as you can and as safe as you can? Because that's ultimately the goal of every developer out there. And that's where Move was born. It was the smart contracts platform, kind of from the predecessor of the Aptos blockchain, which is called Diem, from a project I worked at for many years before we started Aptos. The next thing was As I mentioned, we're super early. 1996 in terms of internet terms. This industry has a lot of ways to grow, not just from a technology standpoint, but from an application standpoint. And as the applications start to develop, you'll develop new kinds of patterns, new types of challenges that erupt with respect to concurrency, parallelism, composability. And that blockchain needs to be able to support upgrades very rapidly to get these developer needs met. Obviously, high throughput, low latency is going to be key for every database that you use. So this is going to be true for blockchain or centralized databases. I used to work in analytics for a long time. I worked on Spark and Hadoop, as well as other things in the data infrastructure space like distributed scheduling. And I ultimately also, before this, I worked in high-performance computing for many years, running things like protein folding, finite element analysis, and some of the nation's largest computers at Los Alamos, Argonne, and Sandia. And so being able to produce a software stack that can scale as you throw more resources at it is really, really important. And so we've come up with a modular and a pipeline design that allows you to improve your transaction processing as you get more resources. So one of the other things that we've talked about is a novel parallel transaction execution engine, and that's what we call Block STM. Taking advantage of the techniques of software transactional memory that were really cool research topics when I was a grad student, but actually very practical towards how you think about optimistic concurrency control and how they can support parallelism without breaking composability. In future, as I mentioned, the goal for this year for Aptos is going to be about how do you support scaling this infrastructure to not just one machine, which is going to be limited in terms of the decentralization you can support, but towards clusters of machines. So a validator should be able to support scaling up its resources with respect to more hardware, better hardware, but also over time, more machines. And this scaling will allow you to think about how, again, like as your application grows, cloud services are able to support this very efficiently. Blockchain should be able to do exactly the same. When you think about intuitive and safer experiences, I think there's a lot of things we can do here. I just want to touch on a couple that we're doing at Aptos that we find pretty interesting. The first is, we thought very heavily about the signature schemes and public key encryption. And the first thing is, very basic. How do you rotate your key? You should do this for a couple of reasons, right? I mean, you change your password periodically because you don't want to get scammed every now and then. We never rotate our keys on the blockchain, and that's even more worrisome because there's chances of brute force attacks, there's chances of your password leaking. It's just a good hygiene to do that. And there's also reasons you need to rotate your key in case you've lost it, in case you've lost access to your the ability to sign transactions going forward. And so Aptos allows you a lot of flexibility with this. First of all, out of the box, you're able to rotate your key, which is a good thing. The second thing is actually you can delegate the control of rotating that key to a smart contract itself. And that smart contract enables all kinds of possibilities. First of all, you could imagine a situation of a semi-custodial model where I've lost my key and I have a way to delegate the control to rotate my key to a third party, someone I trust or a custodian I trust. But I don't want to give them full control to do this all the time. And so you can imagine a time lock where I could wait, if I haven't transacted on chain for 6 months, it probably means either I'm no longer interested in Web3 or I've really lost my key. And at that point, you can verifiably rotate my key because you'll check on chain to see I haven't transacted in that period of time and do it safely. Also, that process would be completely auditable and verifiable. Anyone can see exactly when that was rotated and exactly that it followed the rules on chain to support it through the smart contract. You can then support other kinds of things too, which become interesting. You could imagine I could have multiple signing keys for my account, one for each of my devices, and allow rotation of those. So this kind of composability with a smart contract and thinking about how you manage your account is something that is, I think, pretty interesting to Aptos and novel. And we'd love to see people take advantage of that and try out different strategies for custody solutions, both custodial and non-custodial in the future. The second thing is, of course, the YOLO transaction signing that we see all the time out there. You see something pop in your Chrome browser, you kind of click accept, who knows what the heck has happened. And so that's where we think human readable transactions are really important prior to signing the transaction outcomes. And when you have something like Move, and the way Aptos blockchain is structured, it's pretty simple. Before you sign a transaction, you send it off to a flow node, it executes the transaction on your behalf, it captures the events, the state outcomes, and puts it into a format in which you can understand. And you can decide whether this is a good thing to do or a bad thing to do before you sign off on it. Over time, we're thinking about also adding different kinds of constraints there. So as a part of that transaction that's being constructed, you can put a constraint that says, I do not want more than 50 tokens transferred out of my account as a part of this transaction, guaranteed. That's a nice constraint to put in. Another one would be like, I don't want any of my NFTs to be moved as a part of this transaction. And so the more kind of constraints we can put in also, we can safeguard accounts better for every single user out there. Something that we've also thought about when we think about the safety of your transaction signing is viability limits. Once you sign something, you need to make sure that it does expire over time if it's not submitted on chain. And so we have support for sequence numbers, which means that if you actually write past your sequence number, the old sequence numbers you've signed are no longer valid if they're either on chain or they're expired at that point. Another thing we do is we have a very low latency clock in Aptos. It's updated every single block that's processed. And so you can also specify as a part of your expiration time, after a minute or 2 minutes, I no longer want this transaction to be valid. And so this again provides another form of safety for the user that after you sign your transaction, either the expiration time has been hit and it's been committed on chain, or it's not been hit. And if it's not there on chain, you're guaranteed that it will never be on chain. And the final thing is thinking about how you support light client proofs practically. Today, light client proofs are available in a number of systems. Unfortunately, none of them are actually used much in practice, and that's kind of a shame. But one thing that I think really helps a lot here is that having that very fine-grained timestamp understands how you can look at a proof, you have a timestamp associated with it, you have high confidence that proof is still valid with respect to your verification of your data. So these are just a couple of things that we think through with respect to the safety of the user experience. And I just have an illustration here of me drawing a bar bear and showing you kind of the exact payload, the networking fees. You can click through the raw write sets, the raw events, and understand exactly what this transaction is doing prior to signing it. Let's talk a little bit about Move. Move is a newish language. It was started around 2018, back when I was at Facebook Meta, designed as a new smart contracts language. And I think it was really inspired by the ideas of what Ethereum was doing, in the sense that it was the first smart contract language out there, but also inspired very heavily by things like Rust. And for those of you who've programmed with Rust before in the past, it's got an amazing ability to make you a better programmer by forcing you to fail make all your errors at compile time. And that's great, right? That means less chances of your errors happening at runtime in code. And some of those principles, I think, were really taken seriously when thinking about Move. So Move is a very simple language in some sense. It doesn't support dynamic dispatch. It doesn't have crazy ways of doing things. And because of that, it's very easy to start with something small and grow it over time. But maybe more importantly, it also supports things like formal verification very easily. And so you have the Move prover that's built in, supports all Aptos smart contracts, and you can get formal verification for testing for your smart contract almost for free. You can program a specification and help that smart contract understand, like, these are the constraints that should not be violated, no matter what inputs are put into it. And again, when you can do that, the cool thing is that now, as a part of every unit test you run, every time you make a change to that contract, you kind of get that testing for free. And again, our idea is how do you get from ideation to production as fast as possible? Part of that process is how do you put in great unit testing? How do you have high confidence that every change you make is going to be safe? And so formal verification can be a nice part of that. It can't be the whole thing, of course. You still need to go through audits to check kind of the higher level natures of your code. But definitely it's a great tool to have in the tool bag. And with something like Move, it just makes it harder for you to kind of make those mistakes. Let me give you an example. When you track tokens, there's a coin type. That coin will not allow you to do things that would be mistakes. You can't drop it on the floor. You can't actually take it to an exponent to like a number or a power. You can't add it and subtract it arbitrarily. You have to conserve this resource. And this will fail if you try to do anything other than that in the program. This is an area where, again, we try to fail first, fail early and often, and then that we think that actually provides a faster experience, again, to getting your code into production. Same thing, you can't destroy it accidentally. And now Move, although it's been around since 2018, it has the need for adoption over time. And so we start to add some really new things into it as we have listened to our developers, as developers themselves start to deploy these features into Move, and as the Move community itself starts to grow in volume and scale. A couple of things that I did want to highlight. One is that you have higher order inline functions for collections, which are really cool. So Lambda functions you're used to in many different programming languages that can allow you to simplify your code, make fewer mistakes. We've added something called resource groups. Resource groups are the ability to, as a logical thought process, you have a structure, a set of structures. And how do you kind of pack those structures into a storage slot is something you can control with a resource group. So this allows the programmer extreme optimization about how they take their logical concepts and data model and then turn them into physical manifestation with respect to how much space you're taking, what are the gas fees associated with that, the execution costs, and all that. Another thing we're super excited about is move objects in AIP 10. That's something that's gone live already today. It allows you to kind of compose structures with different capabilities. For example, if you're playing a game and you have a character holding a sword, that sword may have an attribute on it, like a special power. That sword may break over time. And you can actually construct series of NFTs and dependency trees of NFTs that kind of mutate and compose in unique and interesting ways. And so that's what Move Objects provides. It's live today in Aptos, just I think as of a couple weeks ago. And so I do want to talk about upgradability a bit more. As I mentioned, we're early. We need to keep changing things. And it's not enough to just talk about it, but more important to do it. And so we launched Aptos blockchain back in October of last year. And since then, we've hit almost monthly milestones starting in February. We had a February release 1.2, 1.3 launch next month, 1.4 month and a half out there, and 1.5 already in progress. And every release has brought pretty significant changes with it. Those move features I've talked about, new cryptography primitives, and also coming forward in 1.5, there's a really exciting part of it called Quorum Store. Quorum Store is our kind of our production-grade implementation of a research paper that our team contributed towards called Narwhal and Tusk, and the Narwhal part of it, which is data dissemination at scale, which is an important part of how do we scale to large amounts of throughput. And so kind of just walking through again why we need to do these technology upgrades is that you have new tech we're developing all the time. We're working on the skin technologies, working on kind of core protocol primitive improvements. We also have many different customers that are coming to us with new asks. Move objects were something that a South Korean gaming company came to us with and said, we'd love better ideas of how you think about composability going forward. Let's partner together on an AIP, which is our kind of equivalent of EIPs, and build this together. And the way we can upgrade so easily is because a lot of this state is actually stored on chain itself. The kind of process, the kind of flags, and as well as the feature sets. And so it's very easy for validators to sync state to the latest state, understand what the parameters ought to be for the system, and then use them automatically whenever you use governance going forward. So it's a really simple process. It's something that we baked in from the very beginning, and we think is really important as an industry, considering where we are. When it comes to the upgrades itself, there are kind of three different types of upgrades we talk about. So one is the validator software itself. This means pushing new binaries and each of the validators kind of picking them up and running with them. There's also the kind of core protocol improvements. So as I mentioned, if we change our consensus protocol, or if we change the way we handle networking, those are kind of those improvements. And then we also have framework upgrades, which add, it's almost like a standard library for Move. So supporting new kinds of staking contracts, supporting different kinds of object primitives, supporting even different ways to handle, interactions between, again, your count and the smart contracts for key management. All those things can happen as a part of the upgrade process. So I want to walk into our design and infrastructure a little bit more. And as I mentioned, the key thing here is how do you take a software stack that can be decomposed and run on not just one machine, but maybe multi-core, multi-SSD, and yet over time, even across multiple machines internally within the validator. And that we think is really important. And when we designed this infrastructure, we did it in a way where we took advantage of kind of what modern day CPUs do. They're super scalar. They support the ability for pipelining, and this allows like really good high throughput as well as kind of low latency, and allows each of the stages to be parallelized internally. And so the first phase of our pipeline is what we call continuous transaction dissemination. This is based heavily, again, on our research work with Narwhal and Tusk. The idea is that every validator will continuously send blocks of transactions to other validators and produce what we call a proof of availability. That proof of availability guarantees that this validator says, I'm going to store that data for a period of time until expiration happens. And so with that proof of availability, you don't need to kind of worry about pushing that data off in consensus. Because traditionally, I think all data has been sent as a part of consensus, and that makes consensus very slow. And that kind of led, I think, to this misnomer that consensus is actually a slow part of the process. It's not. Consensus is actually very fast. Consensus itself is just a little bit of message passing between machines. But when you start to pack things into it, that becomes very inefficient. So packing in data dissemination, packing in execution can make consensus very, very slow. And so when we thought about design, we pushed those phases out of the bottleneck. So transaction dissemination can happen continuously. Imagine a world where validators continuously accept transactions from the outside world, and they're pushing these blocks of transactions to other validators in parallel. So this kind of scales up with the number of validators you have, or with validators becoming more and more powerful over time, maybe limited only by the network bandwidth. But as you start across multiple machines, again, this becomes less of an issue. Because those multiple machines will have more bandwidth. As long as the internal cluster has significant bandwidth, sufficient bandwidth, you'll get great performance. The next phase we talk about is the ordering of these block metadatas. And so even though validators are continuously generating proof availabilities on lots and lots of blocks, they can start to order these blocks without even having knowledge of them. As long as that metadata is passed around and ordered by the validators, they can agree on initial ordering. This may not even be the final ordering in which transactions are executed, but at least there's some initial ordering, and that initial ordering is very important towards the following stages. Next, we have parallel execution. This relies on essentially our block STM work, where validators will execute transactions in parallel. And the cool thing about this is that we take a very different approach from other blockchains. So many of them, for parallelism, they force users to put data dependencies on their transactions. And this can break composability. For instance, you have a transaction in which you don't know exactly all the data you need to access. You don't know if this is the winner of the auction. You may not know, for example, if I need to look into a secondary index. And this is a limiting factor in terms of programmability. You have to kind of split your transactions up into multiple transactions. And then that adds more latency, more overhead, more signature signing, all the following things you don't really want. And so the cool thing about block STM is actually you don't need to do this. When you control your transaction, the block STM runtime engine will determine automatically what dependencies are required and then parallelize as best as possible. And so that's kind of a really different way of doing things. Over time, I think we also, like, as I mentioned, we want to add more hints to transactions to support protecting users from the situation in which, again, you have unintended side effects. You didn't want to move any of your NFTs, and that can be actually something guarded by the transaction execution engine itself. The next phase is what we call batch storage. I used to work in high-performance computing, and so a lot of my work actually was thinking about how do you batch together storage operations across thousands of supercomputers so that you don't run into the I/O seek problem. Very simple example, if I write 1 byte at a time from 10 different processes versus writing 10 bytes from one process, you're going to see a significant difference in latency and throughput. And so as we process blocks and blocks of transactions, you can compute global state changes on a batch. And the more batching you can do, the better I/O performance you can get from your I/O devices. You have fewer seeks, more efficiency. The final phase is how do you think about generating the state proofs for certification? And this can happen really outside of the critical path. As long as you have generated the execution outputs, everyone can kind of replicate those same things. This is really a way for light clients to be able to prove that the execution results are as expected. And in parallel execution, the other kind of cool thing you can do is reorder things. Remember, you have initial ordering of transactions from the first phase of block metadata ordering. As long as validators deterministically reorder, they can do things like optimize for concurrency, optimize for gas fees, even do things to support randomization if necessary. So this is kind of like our high-level architecture and design. The great thing about it is that every stage can be run in parallel as well. You don't need to wait for one another. You don't need to block. And each of these stages is parallelizable as well. So I did want to dive into block system a little bit because it's one of the core components of our system. And what does it do? It allows and infers that parallelism without programmer assistance. So instead of having to specify, these are my data dependencies, and if I need to do more than that and I don't know what they are, I will either have to block the whole system or I have to split my transaction into multiple transactions. Block system takes care of that for you. It's, again, very similar to optimistic concurrency control in traditional databases, something that's been used for many, many decades in that field. And what we've seen in our performance results is that this scales incredibly well. As long as you have more resources and as long as you have great parallelism, you're going to get incredible performance, pretty much linear with respect to the contention that you have. Now, I do want to talk about performance a little bit. I think it's an area that, unfortunately, is very misunderstood in our space. What is a transaction? How do you count, how do you measure transactions from one network to another, even from workload to workload? And so I think it starts off with how do you define that transaction? And the way we define a transaction is, in our system, we have also what's called metadata transactions. periodically, validators will actually synchronize in order to upgrade our high-performance clock. As I mentioned, we have a clock that kind of updates with every block. And so that clock is updated sub-second. It is a BFT-based clock, which means it's probably one of the most accurate clocks in the world. But we don't count that as a user-signed transaction. It's not something that's generated by users. It's something generated by validators that are signed off on it. And so when we think about user transactions and the benchmarking for that, these transactions may be one or more operations. They may be very complex. They may be very simple. But they're all like one single logical unit of work. And so even if you have 100 user actions signed off by one user, we count that one transaction. We do not count votes as transactions. We do not count system transactions. That's how we think about transactions going forward. The other thing is that transactions, TPC has done a really good job in this space. So I don't know if you're familiar with databases out there. But in database land, there's been a series of benchmarks that have come out with respect to different types of workloads. And so there may be a workload specific to certain areas of finance, a workload specific to big areas of large-scale analytics. And each of these benchmarks serves a very important purpose to have databases compare their performance to one another in different types of workloads. Some actually may be very good for some, and some may be very bad for others. And so we think over time in industry, it's really important that we start to build the same kind of benchmarks. We don't have those today. And so it makes it very hard for us to understand, when a network is talking about their performance, how do you compare it to another network's performance going forward? And finally, the last point is openness and reproducible results are really key towards building credibility in the space. Not just, again, comparison between networks, but credibility as an industry. When database folks look at our work, we want them to show that this is reproducible. This is something that you can run for yourself. This is something that actually represents a real user workload that is important for the industry going forward. And so we actually have a blog post coming soon, if it's not out already, coming out later today or tomorrow, which describes kind of our initial results and our initial benchmark setup. And any one of you can go ahead, as long as you have the money to do so, spin up a cluster, rerun the exact parameters we have, and kind of replicate exactly the same results that we have done. Walking through scaling blockchains like cloud a little bit more. And so this kind of refers to the idea, as we throw more machines into the problem, how do we kind of get better performance? And we think of this as a very kind of, it's not an easy problem, but we simplify it by thinking about it as in stages. The first is the consensus part. And as we talked about, our quorum store capabilities through Narwhal and allowing us to scale to more and more machines is pretty much an infinitely scaling horizontal technology. The more machines I add to the cluster, the more network bandwidth I get. As long as I have reasonably high network bandwidth within that cluster, there's going to be no issues here for scalability. And that's, I think, not an issue for any kind of local cluster. The second phase is how you do the parallel execution. And we have block STM. And so what we've seen is, even for a single machine, you can get about 160K TPS on execution results. If you scale that out further, every machine I add is going to literally improve the throughput of the execution engine. And the final phase is how do you handle storage scalability? Well, we've been working through techniques around taking our jellyfish Merkle tree and parallelizing it and optimizing those data structures for adding on more storage devices, as well as more computers in that space. And so we think that this series of techniques are going to be really important towards getting towards that cloud-like scalability, going from one machine to two machines to three machines and more, and handling any kind of workload that's necessary for the internet to throw at us. Now I want to walk through a little bit on the industry application side, and we kind of want to talk through four and give kind of our view and perspective on how we see these industries evolving with respect to blockchain adoption. The first area is gaming. Gaming, as you may know, is a huge industry. I'm sure a lot of you are gamers right here, right now. There are 3 billion in the world, out of the 8 billion people that are out there. $200 billion revenue industry. It's in the APAC region. I think half of that revenue, almost half, comes from that area. And the great thing about this space is that people are very used to virtual worlds and virtual economies. They brought millions of people together in different ways that were never thought possible. And they have vibrant ecosystems. Their economics are even more complicated in a blockchain, in my perspective. And when surveyed about the thoughts about ownership and transferability, they were very positive. 60% of gamers said they would be likely to invest in digital assets if they're transferable between games, which indicates a desire for those assets to live beyond the lifecycle of a single game. And 84% of developers would create in-game items for the same reasons. And so that's something that we find super, super encouraging in the space. And I think the blockers that we mentioned are really that the experience must be seamless. Instead of focusing on, say, the economics aspects of it, fun, intuitiveness needs to be the most important. And blockchain as a trustless layer is not everything, right? It's not the whole game engine. But it should support things like gameplay, ownership, and built-in operability. That's one thing you get for free with blockchain. everything that's on the chain, anyone can interact with. They can read it, and they can write to their own primitives and their own NFTs. And finally, as we think through like what are the primitives that are necessary to add this utility, composer dynamic NFTs are important. We think on-chain randomness is a really key part of gameplay, not just for games, but even for any kind of online sports platforms. And we also think that as a part of making the user experience really native and kind of seamless the same way that internet games are today, you need to be able to support things like even delegating transaction fees to a third party. So one of the case studies we have for Aptos is through a company called nPixel. nPixel is a company of about 500 person company in South Korea. They've been building AAA games for a long time, and they're starting to build in Web3. And they partnered with Aptos because they saw it as a great opportunity for them to be creative and be explorers in the space and kind of push the boundaries of what's possible in the gaming aspects. And so a couple of things they've been doing is one's called proof of play. It's the idea that as you support this kind of discovery or randomness of rare items, how do you control the quantity? How do you control when it's distributed over a period? And how do you explain this to users in a way that they can understand so they know that when they get their objects, their tokens, the value of those tokens over time with respect to the utility in the game. That's one thing that's really cool. The other thing they're doing is actually exploring the idea of how do you support transactions with Aptos that have different billing accounts. So as a user, I'm playing a game, I can send a transaction. The fees of that transaction can actually be billed to a third party, to either the game developer itself or to another custodian. And this means as a user, I don't even need to have an on-chain account necessarily, which is really cool. And the third thing, as I mentioned, is on-chain randomness. The ability for them to compute randomness functions very quickly. When you open up a treasure chest, what kind of items you're going to get? Is it provably random? If you're playing a game and there's an element of randomness to, like when you strike someone with a sword, how much damage does it do? All these things can be done with on-chain randomness that is unbiasable and something that is purely transparent and auditable as well in the future. So super excited about the work that they're doing. No, sorry, not sure what's going on here. It's not able to advance. Yeah. Some of the clickers are a little bit stuck here. Sorry. Okay. Let's go back a little bit. Okay, great. The next use case I'd love to talk about is social. It's not just because I worked at Meta for 10 years. I do think social is something that obviously has a huge use case, more than 5 billion users worldwide. Mobile is definitely a big area for where social interactions happen today. And the time that people spend in social media products really much rivals kind of what happens in TV today, which is just incredible. And when we were at Meta, some of the interesting challenges we saw were around ownership and content moderation. And these kind of challenges, I think, are really ripe for what blockchain can do extremely well. So having creators kind of control when I post something to Facebook or Instagram, what Instagram and Facebook do with that data. Are they allowed to use it as a part of ad targeting? Are they allowed to share it with this set of users that I don't want them to share it with? That's something that I control as a user going forward with blockchain, and something that Facebook would definitely respect. Also, the ability for content creators to be rewarded for that through even even just if it's online on-chain and having that kind of reputation, not just being in one application, but if I then go to Instagram or I go to YouTube or I go to Quora or Stack Overflow, that reputation kind of comes with me as I move throughout those spaces in different worlds. So that's something that's really interesting. The other interesting aspect is content moderation. It's very hard for a centralized platform to moderate things. They always make someone unhappy. Whether it's the Democrats or Republicans or whether it's liberals or conservatives, people always get upset when you moderate their content. And so allowing decentralized moderation through committees or through individuals and individualized voting, which is tricky, but forming these kind of governance structures and voting structures that allow these companies to kind of have that problem settled by the community as opposed to themselves is something that could be really important and interesting. And the final thing is going to be around creator relationships. So we want to make sure that creators are connected closer to their fans. If Steph Curry's playing in a game, he definitely and he wants to connect directly with his audience. How can he do that? Maybe through NFT token gating, maybe through drops. There's a lot of things that can be done there. And with respect to the on-chain randomness and blending, we can also support interesting avenues of gaming and creator relationships put together. Aspects of like, maybe as a creator, I want my audience and fans to be able to, play a kind of raffle lottery and win one of my special NFTs, if that's something that's interesting to them. So just being allowed this kind of social aspects to be kind of using the utility of blockchain and enhance them is something that we're really, really excited about going forward. One of the use cases we do want to call out here is a project called Chingari. They've got 175 million downloads. They have 45 million monthly active users today, and 2 million on-chain users. And they're one of the largest social media platforms in India, Indonesia, and Turkey. They're actually living this dream out. So they have a way for creators to actually connect with their fans. They can buy, own, and trade video NFTs. They can tip those creators with Gari token. And they have a very simple wallet for onboarding. So we definitely see that these kind of ecosystems are starting to develop in different products. And we're really excited about kind of like, this may not yet be at meta scale where you have billions of users, but getting to tens of millions or maybe hundreds of millions of users over time is something where you can start to see the effects of blockchain utility being brought into different platforms. Another area we're really excited about is the media and entertainment area. And so thinking about some of the challenges there, they're starting to think about how you can do direct content distribution. So music or TV shows, how do you get those directly from the producer directly to the consumer? And how do you cut out kind of the intermediaries? How do you support rentals and transition of content ownership in that space? And the creator relationship is something that is really exciting. Having those publishers directly interact with fans. And so one use case I'll call out here is, let me go to the next slide, is what we've done with Renfield. And so Renfield was didn't you see Renfield yet? No? It's a pretty cool movie. It's about kind of taking the story of Dracula and his assistant Renfield. And in order to kind of bridge this gap of how does media interact with kind of in real life experiences, NBC Universal partnered with Aptos Labs with respect to building a new game. Free Renfield is really fun. You play it, you identify some bugs you can eat, and then you can win NFTs and different prizes. And this experiment was also run with Fandango. And now the idea is that you have these digital online experiences that kind of connect you more to the product and to the experience yourself. And they were really excited about the results. Lots of people play the game. Lots of people use that game as a way to get more interested in the movie and the product. And this campaign will be expanding to other movies and other platforms going forward. Similarly in this space, what we've seen is with respect to ticketing. Let's take the element of ticketing itself. There's a company called Kid Labs who's working closely with Aptos on how do you kind of connect concert goers directly with concert organizers and event goers alike. And this is really neat. So even recently we had a NFT Renfield event at NFT NYC, and more than 1K people registered through the application. The tickets were checked at the door, kind of just proving out the power of the product. And ticketing, while maybe not the most exciting use case, is maybe one of the most interesting ones for blockchain. It definitely fixes all the problems of fraud when you transfer tickets from one party to another. You can kind of prove these tickets are authentic, that you are the owner of those contents as opposed to kind of buying them from a scalper, which is always a very interesting experience. And we're really excited about the direction of where kind of in real life experiences, ticketing, as well as the ability to kind of generate interest through blockchain on media is going to be moving that platform forward. Finance is kind of another area that's really interesting. Some of you may know this or not, but the Libra blockchain and DM blockchain was actually built specifically to be a payments and remittance network. And so it's definitely an area that's kind of core to our hearts. It is maybe one of the best use cases for blockchain in the world. There's just so many things you can do here. One of them is, of course, identity verification. Being able to prove who you are, that you're allowed to transact in this particular region, country, you're of a certain age, without having to necessarily reveal your personal identification is a really nice feature. And being able to take that identity and prove it with a mobile phone as opposed to carrying around a passport is even more valuable. Decentralized exchanges, I think we all know that what happens when you don't control your assets, they might not be there over time. And so the way that we can help with decentralized exchanges is trying to improve the throughput of blockchains, improve the usability aspects, and make it more mainstream going forward. But the advantages are huge. having that control of those assets, making sure the transactions are recorded and auditable are really important benefits that we want to bring to society. For payments, I think Visa averages around 2,000 transactions a second. But these transactions, and in peaks of 60,000 plus, but these payments are not necessarily settled. They're kind of approved. And so the ability to settle transactions instantaneously in sub-second finality is something that can really move the needle here and something that we're really excited about. Finally, right here, I think companies are talking about tokenizing assets on-chain. That's exciting. It supports fractionalization of those assets. All the transactions are auditable and immutable. And everything becomes more accessible for a larger audience to interact with. And so definitely use cases that I think over time we're going to see our industry start to take on much more broadly. Some of the interesting use cases we see on Aptos that are exciting are a couple of startups that are building in the space. One is Thala Labs, another one's Iconia. And so Iconia is this really interesting new order book in which you can kind of clear trades on multiple markets in parallel. You get the maximum throughput, you get a crankless order book, and that's because of the fact you have block STM paired with the composability aspect of not necessarily having to declare dependencies up front, which makes things a lot simpler. On Thala, you get these Web2-like experiences on DeFi. Your optimizations your gas structures are extremely cheap, less than 1 second average, and the fast finality time makes it feel very much like a normal internet application you're dealing with. So I would like to conclude and leave you with a couple of things. One thing is the industry is super, super early. Less than 0.2% of internet users use the blockchain. We got a long way to go here. The other thing is that blockchain infrastructure is going to need to develop rapidly and continuously innovate over the coming decades. This is not something that's going to happen in a year or two. And so that need to keep pushing that technology boundary forward in terms of better throughput, better performance, better scalability, the same way the cloud does, is really important. And as I mentioned, there are kind of two blockers here. One we see is user experience with the blockchain need to be as good as the internet today. You've got to be able to do things as well and simple as Amazon, as Google, as Netflix, and there's just no way around that. And finally, we see the beginnings of industry transformation starting to happen. Some of these aspects and value adds that we've identified are starting to make their way into products, and that's a really good sign. And the industries are large, it will take time, but we do believe that they are the right ones for seeing kind of the utility come first in our space. And so with that, I'm done. I do believe we might have a little extra time, so I thought this is the last session of the day. If we want to do a Q&A, that might be kind of fun. So.
Hello? Oh, great. Yeah, so BC, Wonder Arena. Yeah, thank you for the talk. I was wondering, since you mentioned all these big industries, and it's of course really exciting if they all ended up using Aptos. But I was wondering, why would, since we have more new layer 1 solutions now, why would these companies, projects go to Aptos instead of something like a similar L1 solution like Sui or Flow blockchain? Yeah.
Great question. I think what we want to see over time is how do these blockchains support those use cases really well? And so it's hard to say right now. It kind of goes back to the benchmarking question I have a little bit. We need to be able to translate these workloads into benchmarks to some degree and understand the performance of different blockchains over time, and also the different ways things are built. Not everything is good for everything, right? I think for us at Aptos, one thing we're doing again is pushing very hard on the idea of horizontally scaling our blockchain across multiple machines. This has other trade-offs. And so as you see the trade-offs that happen between layer 1s, I do believe there will be spaces for several of them to compete in the future. Another way to think about it is, let's look at cloud for a second. There are many cloud providers. Obviously, there are a small number that kind of dominate the market that we called out, like Amazon, Google, and Azure. I do think that in blockchain space, we might get to that point in time, but it's early on. And again, the technology is really early. So we'll have to kind of try things and experiment as an industry. I do expect many applications to try on different platforms, and over time, the best ones will adopt most of the workload.
So Aptos is not EVM compatible and it uses a separate language than Solidity. So that would require people to learn the language first, then build on Aptos. So what's your plan on that? Like, how would you spread the awareness and how would you educate people on learning that language? I mean, Solana faced the same issue. So what are your plans to educate the builders on that?
That's a wonderful question. I think that's definitely always a trade-off when you introduce a new language into any ecosystem, by the way. This is not unique to the blockchain space. So for us, as you would introduce a new language, what do? You test it. We had hackathons in early May of last year where we took people that just knew how to code and they tried to build things. And what we found is that we had the same concerns. But within 36 hours, they had built wallets, NFT marketplaces, games. These are people with no prior experience. And this is also when our docs were not the greatest place, to be honest. So that gave us a lot of encouragement about Move. And as we see the community starting to develop, it's been 6 months since our mainnet launch, give or take. More than 130 projects are live. Most of them who have never talked to us, maybe just read through the documentation, the Move book, and be able to build on their own. So we've been super excited about the way the communities come together with learning and adopting Move and getting, understanding some of the benefits behind it. A lot of them say, working on Move makes you, some people exaggerate, like 100x more productive. I'm like, that's probably not the case, but even if it's just 10x or 5x or 3x more productive, that's something they can tangibly understand for themselves. And the other thing I wanted to talk about that question is, we're really excited about actually things like ChatGPT. ChatGPT, we've been playing around with it a little bit, and actually it can help you construct some of the basic things for your project. And so having that as a developer plugin and saying like, well, can you write me a very simple escrow contract? Can you add some can you add some specifications for formal verification in the Move prover? You can start to do some of that stuff. It's not perfect, but it definitely shows a pathway of how you can kind of get some skeleton code going and start to build in that space. So a lot of exciting things with Move. The other thing I wanted to comment about Move specifically and why we like it so much is not just because of the way it's been developed, but also where it's going. The EVM ecosystem is very large, and that's great, but it also does not move very quickly going forward. And that part of it is because it's so large, right? It's hard to get all the parties to agree on like what changes should be made to push it forward in the future. Move is quick. We can deploy a new feature like Move objects in less than a month. We can add Lambda functions in a week or two. These things can happen very quickly, and as we talk to more developers, as we iterate in the space, we can actually work that language towards developer needs over time, which is really cool.
Hello, I'm Stella, and I'm a developer of the D app. So actually, my question is going to be more from my personal perspective. So I'm wondering if Aptos are looking for any D app or like any application based on the Aptos protocols. And also, I want to know like what's your strategy for the next step if you really want to onboard like more developers, more apps on this chain.
Great question, and thanks for your question. So we are hosting 4 hackathons this year. We had one in Seoul earlier. Hundreds of people came, and it was a really cool event. We have one coming up in Amsterdam, and we have 2 more planned for the rest of the year. So it's definitely one way you can get involved. We'll be hosting some virtual hackathons as well, which are good ways to connect with the community. And we also the Aptos Foundation has a grant program where it calls out specific areas of interest. I think very closely aligned to the kind of categories I laid out that they want to see builders building on. So lots of different ways to communicate and participate. There's also an artist grants program for those who want to do things that kind of push the boundaries in terms of creativity. Things like generative art and AI. All those things are definitely things that the Aptos Foundation would love to support.
Hi, my name is Jake. My question's more, I guess not Aptos specific, but just more around blockchain with content verification. So obviously we've all, like you talked about ChatGPT, seen the amazing things the AI can do lately, but we've also seen, like I'm sure, some horrific things or just scary things where you're like, wow, that looks way too real to be AI generated. So where do you see both blockchain and Aptos specifically fitting in for content verification and, in social media, gaming, etc.?
Yeah, it's a great question. There are definitely the pros and cons of all technology, and I think you've hit on some of the things are a little scary in terms of being how do we know what's real, what's not real. I do think blockchain probably can't do much to stop generative AI from becoming too powerful. I think that's not the goal of what it would be. But it can definitely do things like help traceability of how content changes over time. And so as creators start to control their content more and kind of put their ownership receipts on chain and in a scalable way, that can be like, you can definitely specify things like, hey, don't modify my content or don't use my content without my permission. And while not everyone will respect that, you can imagine that larger institutions and enterprise businesses would, because they want to not violate user rights. And so I think that blockchain can actually serve as a very nice platform for having that kind of control listed and hopefully followed by those kind of parties.
All right, maybe just like 2 more.
Sure. I know you're getting tired, John, of walking around.
Hi, this is Swaroop from Pi Network. You mentioned on your slides on-chain randomness a couple of times. Just wondering what you mean by that.
Great question. So there are techniques like DRAN. I don't know if you follow. So basically, there are on-chain oracles that push data to chain. That's definitely one path that others have taken. I think that is a reasonable kind of intermediate solution for us. But what we're thinking about is the same way we have a kind of very high-performance Byzantine fault-tolerant clock on chain. This is through kind of very long conversation, but basically every validator is kind of continuously producing data for the clocks. Clocks are being compared, and you don't validate clocks until a certain period of time, and therefore, as long as 2/3 the majority are honest, you are ensured that your clock will always be increasing in time and also be very accurate. The same thing we want to kind of do for there is apply to randomness. So validators will contribute portions of kind of like toward randomness. And those randomness will be aggregated in a way that kind of respects the stake of the validators. And so that kind of on-chain randomness is kind of an oracle that's generated through the validation network itself. And this would allow a very different type of randomness that's provided through oracles. Very low latency randomness that can be used for every single block, for example. And so that we think is really key towards especially things like gaming going forward in the future.
Yeah. Well, thank you for the talk. Great. So I have a question about the finality. How many blocks do you have to wait and for a block to be finalized?
Good question. So today we use a variant of hot stuff, which requires just 2 confirmations. It's something we kind of developed called Jolteon as a paper a couple years ago. Love to see that other blockchains are adopting that same technique, by the way, which is fantastic. So it's just kind of 2 blocks until you kind of get confirmation times. And so blocks usually come very, very quickly in the network. You're usually 2, 3, 4 blocks a second, something like that. So it's really quick in finality times.
All right, let's give it up for Avery and the Aptos team. If you guys want more information, aptosfoundation.org.
Aptosfoundation.org.
Follow Avery, follow Mo on Twitter, get involved, and let's give it up. Thanks again, Avery, for joining us.
Thanks, John.